Next, we are discussing about p-type semiconductor. What is a p-type semiconductor? The small amount of the trivalent impurities adding to the pure semiconductor. It is said to be that p-type semiconductor. What are the example for this? Boron, gallium, indium, aluminium. This is having in valency. It is having the 3 valency electrons are there. So here generally how to adding this one from the diagram you are observing, when you are observing here the silicon is having the 4 valency. Okay, now here the silicon is there, it is at pairing with the silicon, here is also pairing with the silicon. Like this only, if it is suppose the boron is that in middle of the atom, it is having the valency is 3. So here it is that with the silicon is a pairing, here is also the pairing, here is also the pairing, but here the silicon is one electron is there, but it is that electron is not there, means here this is the absence of the electron in the semiconductor is called which one? Hole. Like this only, suppose if it is giving the small energy to this one, then the electron is moving to this place. Here it is appeared the hole. After that, like this only, the electron is moving, then the hole are appeared. Means in this p-type semiconductor, the electricity is giving that only the holes. Like this, suppose majority in this majority carriers are holes and minority carriers are electrons. When you are observing here, this is that valency bond and it is a conduction bond. The valency bond, suppose if it is giving the small energy, then electron goes to this place. Means the majority carriers are here holes. So here the majority carriers are holes. That is, it is having the positive charge. That's why it is called p-type semiconductor. And the Fermi level, when you are observing here, the all the holes are the majority carriers. That's why the Fermi level is nearer to which one? In valency bond, nearer to valence bond. This is a p-type of the semiconductor. And n-type of the semiconductor. What is the n-type semiconductor? When a small amount of the pentavalent impurities, if it is adding to the semiconductor, is said to be n-type semiconductor. Example, phosphorus and arsenic and antimony and added to silicon and germanium. It is having the pentavalent. The valency about these atoms is having the 5. Now you are observing the diagram. It is the phosphorus is if it is adding this one, then in the same before that p-type semiconductor, the silicon is a pairing, here is also pairing, here is also pairing, here is also pairing. The phosphorus is outside of the valence is a 5. So yeah, the p is sharing with the 4 electrons here and remaining 1 electron is there. So here, if it is you are giving the small energy to this, the electron is moving to this one. So yeah, in this in n-type semiconductor, the majority carriers are electrons and minority carriers are holes. And when you are observing here, this is that you are observing in the valency bond, the holes are the less. In conduction bond, the electrons are more. That's why the Fermi level, it is nearer to that conduction bond. And here that electrons are that majority carriers. That's why it is having the negative charge. It is having the negative charge. That's why it is called n-type of the semiconductor. So these are the 2 type of the semiconductors. One is the p-type and n-type. Tomorrow we are discussing about that p-n junction diode.